In this video, we will talk about pooling in convolutional neural network. So, let's get started. In simple words, pooling is used for dimensionality reduction in CNN. But why we need to reduce the dimensions? The answer is, for decreasing the computational power required to train the model. But pooling is not just for reducing the dimension only, in fact, it also helps in extracting the dominant features. So, let's see how pooling works. Pooling works similar to filters. Consider this 4x4 image where we are using a filter of size 2x2. In case of filters, we used to multiply filter values to the input, element-wise, and then calculate the sum. In case of pooling, we still have the filter window, but instead of multiplying we do some operation, like taking max or average within the window. For example, in this image we are having a 2x2 filter with stride 2. Now look at the green area, we have taken the maximum of the 4 values, that is 7. Then the filter moves to the next position, that is the red area, and again, it took the maximum value, that is 10. Similarly, the filter moves to the orange and blue area, and takes the max value from those areas. Now, we can see that the dimension has been reduced from a 4x4 input to a 2x2 output. But, how pooling extract the dominant features? So, we saw in this image that we took the max value of the filter window. And if the filter has detected something, then the maximum value represents those detections, hence taking only that value, or the feature with maximum value, or in other words we are taking only features with higher values and throwing away the redundant information. So, this way pooling helps us in extracting the dominant features. Now, let's see how pooling works with the 3D input image. Consider this 3D image having RGB channels. So, when we apply pooling to 3D image, it works independently on each channel. The filter will first go through the red channel and takes the max values for each window, and then similarly to the green and blue channels. So, for a 3D input we get a 3D output with reduced dimensions. Now, let's take a look at different types of pooling. The first one is the max pooling. We have already discussed this pooling where we take maximum value of the filter window. Next comes the average pooling. It is similar in operation as max pooling. The only difference is instead of taking the maximum of the values, we take the average of the values within the window. After this comes the global average pooling. Earlier, we have seen that if we have a 3D input image, we will get a 3D output. But in global average pooling, if we pass a 3D input, we get a 1D output. This is used when we want the CNN or the feature extraction part to connect to the fully connected part. In global average pooling, the filter size is equal to the size of the entire image. Consider this 4x4 image. So, instead of a 2x2 filter that we used in max pooling and average pooling, the filter size will be 4x4, that is equal to the size of the image. Which means that it takes the average of the entire channel. For example, it will first take the average of entire red channel, then the green and then blue. Then convert it into a 1D vector. Another type of global pooling is the global max pooling. Global max pooling is similar to the global average pooling. The only difference is that instead of taking average we take maximum value of the window. So, this is it for this video. If you liked this video and want me to continue making such videos, then subscribe to the channel. Thank you.